Hello everyone, I am Balaji Rao. Welcome to BR Maths class. This is first class on relations JEE. We do this complete relations objective part in two classes. Next class is scheduled on March 1st. Now you can join in the batch JEE Mathematics 2026. Till now, these are the chapters we completed in this batch. Complete NCERT sets we completed, and sets objective we did it in two parts. Complete NCERT relations is also completed. In this relations, class 11th relations, class 12th relations also we completed. Now we are doing relations objective first class. These classes are completely free on YouTube. However, if you want to support your teacher, if you want my classroom notes, practice materials, you can join in this batch JEE Mathematics 2026. Course link is given in the description. In this video, for each topic, for each question, timestamps are given and directly you can go to that topic. I strongly recommend you to watch these videos in the speed of 1.5 to get good experience. In this class, we will learn reflexive relation, number of reflexive relations, very good examples to understand number of reflexive relations, difference between identity relation and reflexive relation, symmetric relation, number of symmetric relations, and very good examples to understand number of symmetric relations on set A. We will learn what is equivalence relation and number of equivalence relations. You see, this is the question given recently in JEE on number of equivalence relations and some previous year JEE questions on relations topic. See, this is the question given in JEE Main 2024. So these are the things we are going to cover in this video. Before going to start this video, please drop a like for this video and share this video with your friends. In case if you are not yet subscribed to this channel, subscribe now. So without much delay, let's begin the class. In today's class, what we are going to learn? You observe this, we will learn what is reflexive relation and I'll explain what is this reflexive relation with very good examples. Okay, and what is the formula to calculate number of reflexive relations on set A. Okay, and we will learn what is identity relation and we will learn what is the difference between identity relation and reflexive relation. Okay, after that we will learn symmetric relation and we will try to understand these symmetric relations with very good examples so that all doubts, I am considering examples in such a way that all your doubts will be cleared. Such type of examples I am taking. Okay, and see what is the formula to calculate number of symmetric relations on a set A and how to identify given relation is symmetric relation or not. That also we'll discuss. Next, transitive relation. We will learn the definition of transitive relation and I am taking the best examples such that all your doubts will be cleared. I'll take examples to explain what is transitive relation and what are the confusion part of transitive relation. All those things I'll discuss. Okay. After that, what is the definition of equivalence relation? Which relation is called equivalence relation? And for this also I have examples. We will take examples to explain which relation is equivalence relation, which relation is not equivalence relation. Okay. After that, the concept based some objective questions. Reflexive, symmetric, transitive based some objective questions we'll do. These questions we'll do in today's class. Okay. So many students confuse in this relation part, especially class 12 relation part. Reflexive relation, so many doubts will be there. Symmetric relation, so many, especially transitive relation, so many doubts will come. All the doubts I'll clear. Please stay with me. Okay, before going to start this video, please drop a like for this video. Without much delay, let's begin the class. Okay, you see this definition. What is reflexive relation? What is reflexive relation? First point, a relation R on A. What is this? R is a relation on A. R is a relation on set A. What it means? Okay, R is a relation on set A. R is a relation on set A. It means what? R is a relation on set A means R is subset of A cross A. I'll try to explain quickly here. When we say R is a relation on A, suppose if I take A is 1, 2, 3. A cross A contains 9 elements. You know that. Okay. I'll take one subset of A cross A, like 1, 1, 1, 2, whatever elements you take in between 3, 1, 2, 3 only. This is clearly subset of A cross A. If R is subset of A cross A, then R is called relation on A. Okay. So what is relation on A? If R is a relation from A to A, if R is a relation from A to A, then R is called relation on A. If R is subset of A cross A, then R is called relation on A. This we discussed in last class also. What is relation on A means? Okay. The relation is said to be reflexive relation. When we say a relation on set A is reflexive relation, very simple. For every X in set A, for every element X in set A, the order pair X comma X also belongs to the relation. Then we say that this relation is reflexive relation. First thing, a relation R on A is said to be a reflexive relation if for every X belongs to A, the order pair X comma X also belongs to R, then this relation is called reflexive relation. I'll try to explain this by taking one example. Okay, here I'll take one example to explain what is reflexive relation. I'll take a set A. The set A contains 3 elements, 1, 2, 3. Okay. Now I'll take one relation like this. You know A cross A contains 9 elements for this. You want me to write A cross A? I think not necessary. But however, some students may feel difficult. I'll write A cross A. A cross A means what? A cross A means in last class we discussed it now. Here you imagine like this 1, 2, 3. Okay. What is A cross A? A cross A is order pair 1, 1. You take 1 and you pair with all the elements of second set. Okay. What you will get 1, 1, 1, 2. No need of writing all these things, so that why I am writing this, so that every student can understand. 1, 3. Next, take second element of first set and you pair with all the elements of second set. Okay. What you will get? 2, 1, 2, 2, 2, 3. Okay. Now, you take third element of the first set and you pair with all the elements of second set. What you will get? 3, 1, 3, 1, 3, 2, 3, 3. This is A cross A. Set A contains 3 elements. Na? Set A contains 3 elements. Na? So, A cross A contains 9 elements. Okay. I'll take one relation R on A. When we say R is a relation on A, if R is subset of A cross A, you take one relation. I will consider relation like this. Order pair 1, 1, order pair 2, 2, order pair 1, 3. All the elements present in this relation, are present in A cross A. Look here. Order pair 1, 1 is present here. Order pair 2, 2 is present here. Order pair 1, 3 present here. All the elements present in R are present in A cross A. That means R is subset of A cross A. If R is subset of A cross A, then R is called relation on A. First point, R is a relation on this set A. R is the relation on set A. Now this relation is reflexive relation or not? What? When we say the relation is reflexive relation, for every, this is important. For every, don't take lightly. For every, if for every X belongs to A, order pair X comma X belongs to R, then we say the relation is reflexive. For every X belongs to A. Try to understand. You see, in set A, 1 is there. In set A, 1 is there. The order pair 1, 1 is there in the relation. That means, if I take 1 in set A, order pair 1, 1 belongs to the relation. From that, can I say that this relation is a reflexive relation? No. You need to check like that for every X in set A. For every element in set A, you need to check. So, if I take 1 in set A, the order pair 1, 1 belongs to this relation. That means this condition satisfied for the element 1. Now you take the element 2. You take the element 2 and you check that order pair 2, 2 belongs to the relation or not. Yes, order pair 2, 2 belongs to R. For 1, 1, 1 belongs to R. For 2, order pair 2, 2 belongs to R. From this, can I say that this relation is reflexive relation? No. You need to check for every X belongs to A. Here one more element is remaining. Na? That element is 3. That element is 3. Order pair 3, 3 is there in this relation? No. That means what happened? For every X belongs to A, X comma X does not belongs to R for this example. I hope you got this point. Okay. So what I'll write here, this is relation on A, but this is not reflexive. This relation is not reflexive. Why it is not reflexive? When you are saying it is not reflexive, give an example, counter example. For example, here 3 is there in set A, but 3, 3 does not belongs to the relation. 3 is there in set A, but 3, 3 does not belongs to the relation. Because of this reason, we'll say that this relation is R is not reflexive. I hope you got this point. Okay, I'll take one more example to explain. See, these things, explanation, understanding the definition is very, very important. As many examples possible, that many I'll take. Have patience and listen carefully. Okay. Now, this is R1. I'll take one more relation like R2. This relation I'll take like this. Order pair 1, 1, order pair 2, 2, order pair 3 comma 3. First point is R is a relation on A. This R2, I written R2 na, is R2 is relation on A. If R2 is subset of A cross A, then we say that R2 is relation on A. You see here 1 comma 1 is there in A cross A, yes. 2 comma 2 is there in A cross A, yes. 3 comma 3 is there in A cross A, yes. R2 is subset of A cross A, so R2 is relation on A. R2 is relation on A. Now I need to check that is this relation is reflexive relation or not. Is this relation is reflexive relation or not. For every x belongs to A, if order pair x comma x belongs to R, then we say that that relation is reflexive relation. Here you take 1 comma 1 is there. You take 2 from set A, order pair 2 comma 2 is there in the relation. You take element 3, order pair 3 comma 3 is there in this relation. So for every x belongs to A, x comma x belongs to R, this relation satisfies this condition or not. For every is very, very important, right? Yes, for every x belongs to A, x comma x belongs to R. Therefore, what is this relation? This relation is reflexive relation. This relation is reflexive. Okay, what is the reason? If someone asks what is the reason for that, you will write like for every x belongs to A implies the order pair x comma x belongs to the relation. That's why R is reflexive. That's it. That's why R is reflexive. I hope you understand. I'll take one more example. To clear all your doubts, I'll take one more example. R3. R3 I'll take like this. R3. Order pair 1 comma 1. Order pair 1 comma 3. Order pair 2 comma 2. Order pair 3 comma 3. Order pair 3 comma 1. I taken one relation like this. First point is R3 is relation on A. If R3 is subset of A cross A, then R3 is relation on A. You look here 1 comma 1, yes, no, not here. 1 comma 1 is there in A cross A. 1 comma 3 is there in A cross A. 1 comma 3, yes, it is there. 2 comma 2, yes, it is there. 3 comma 3, yes, it is there. 3 comma 1, yes, it is there. R3 is subset of A cross A. So R3 is relation on A. My question is this relation is reflexive? Is this relation is reflexive relation? What is the definition of reflexive relation? For every x belongs to A, the order pair x comma x belongs to R or not. You take 1 in set A. You take 1 in set A. The order pair 1 comma 1 is there in the relation. Yes, it is present in this relation. You take element 2 in set A. The order pair 2 comma 2 is there in this relation. Yes, it is there. You take the element 3 in set A. The order pair 3 comma 3 is there in this relation. Yes, that means what happened? Here, this relation is satisfying this condition. Do not worry about these elements. 1 comma 3, 3 comma 1, even though if 3 comma 1 is not given, you suppose 3 comma 1 is not given. If they given like this, is this relation is reflexive relation or not? Here 1 comma 3 is there, that's why no need. What we want? For every x in set A, the order pair x comma x belongs to the relation or not. That much only you need to check. Okay, here 1 is there in set A, order pair 1 comma 1 is there in the relation. Yes. Or 2 is there in set A, order pair 2 comma 2 is there in this relation. Yes. 3 is there in set A, order pair 3 comma 3 is there in this relation. Yes. Therefore, this relation is reflexive relation. That's it. So we'll write here this relation is reflexive relation on A. Why? If someone asks what is the reason that it is reflexive relation, what is the point? Very simple thing. We'll write the definition. For every x belongs to A, the order pair x comma x belongs to the relation. Because of this reason, we'll say that R is a reflexive relation on A. That's it. Okay. Now, one more example. I can say that there is a chance that you will confuse it easily. Okay. After writing the relation, you just comment whether it is a reflexive relation or not. Okay. I'll take a relation. Like this. R4. I'll take a relation like this. This contains 1 comma 1, 2 comma 2, 2 comma 2, 3 comma 3, 4 comma 4. Okay, I taken a relation like this. Now, is this relation is reflexive on set A? Yes or no? Please comment. Those who are watching the video, please comment. Is this relation is a reflexive relation or not? Anyone comment, please. Is this relation is reflexive relation on set A? Yes or no? Yes. Okay. So you may feel that this relation is reflexive relation on this set. This is not the reflexive relation. Why? Because this is not a relation on A. This is not the relation on A. Okay. Because you look here, 4 comma 4. 4 is not there in set A. 4 comma 4 is not in A cross A. 4 comma 4 is there in A cross A. Check here. 4 comma 4 is there in A cross A. It's not there. First point, this is not a relation on this set. Okay. So, if set A contains 1, 2, 3, 4. If set A contains 1, 2, 3, 4. If that is the case, If set A contains 1, 2, 3, 4, if that is the case, then it is reflexive on set A. But here in this 4 is not there. This is not reflexive on A. Right, I'll write here is not reflexive on A, on given set A, because first thing, it is not a relation, because it is not a relation on A. I hope you understand. In case if you understand this, if you are feeling that yes, good explanation is there, please drop a like and share these videos with your friends so that our channel will grow. Okay, now look here. Very important one. Number of reflexive relations on set A formula. How many reflexive relations we can form on set A? This is the formula. What is the formula? 2 power number of elements in set A whole square minus number of elements in set A. This is the formula to calculate number of reflexive relations. I'll explain by taking one example also. First point, you look here. What is the formula? 2 power n of A, number of elements in set A whole square minus n of A. Okay, for example, you taken set A equal to like this 1, 2. Okay, for this set, how many reflexive relations you will get as per this formula? I'll write here. How many reflexive relations here? Here I'll write. How many reflexive relations? You check here. I'm writing here. How many reflexive relations? Okay, 2 power n of A whole square. N of A contains how many elements? 2 elements are there. 2 square. 2 square means 2 power 4 minus n of A. N of A, set A contains 2 elements, na? 2. That is what? 4 minus 2 is 2. That is 2 square. 2 square is 4. 2 square is 4. So, if set A contains 2 elements, number of reflexive relations on A formula is what? 4 reflexive relations we will get on set A. Now, further I will discuss. Listen this carefully. I taken set A contains 2 elements 1, 2. You know how to calculate A cross A. Set A cross set A. Take first element, pair with all the elements of second set. 1, 1, 1, 2. Take second element, pair with all the elements of this set. 2, 1, 2, 2. A cross A contains how many elements? A cross A contains 4 elements. Number of relations on A formula. Last class we learned number of relations on set A formula is what? Number of relations. I am not saying reflexive relations. Number of relations on A formula is 2 power number of elements in A cross B. 2 power number of elements in A cross B. How many elements are there in A cross B? A cross B, how many elements are there? 4 elements are there. 1, 2, 3, 4. 2 power 4. 2 power 4 is what? 16. If A is the set which contains 2 elements, how many relations we can form on set A? Formula 2 power number of elements in A cross B. 2 power number of elements in A cross B. How many elements are there in A cross B? 4 elements are there. Total 16 relations you will get. You see, this is a subset of A cross A. This is also subset of A cross A. This is also subset of A cross A. You can check here. These are all subsets of A cross A. And I taken these 2 element subsets. These are all subsets of A cross A. And you can look here. These are all subsets of A cross A. So these are all relations. What I am asking, how many relations we can form on set A, right? Number of relation on A means relation from A to A. Number of relations on set A formula is 2 power number of elements in A cross A. That is 2 power 4. That is 16. All the relations I written here. Now the point is, in these 16 relations, you can get only 4 reflexive relations. That 4 reflexive relations you need to identify. Okay. Even though it takes time, please have patience. Try to understand clearly. These things takes time. But once you understand, you can enjoy this chapter like anything. Right? Okay. First you take this relation. Is this relation is reflexive relation? 1, 1. Is this relation is reflexive relation? Please comment. Is this relation is reflexive relation? Yes. Is this relation is reflexive relation? No. Why? For every x belongs to A. What is the definition of reflexive relation? Look here. For every x belongs to A, order pair x, x belongs to this relation. Here, 1 is there in set A. 1, 1 is there. It's okay. But when you take 2 in set A, the order pair 2, 2 not in this. This is not reflexive. R1 is not reflexive. I'll just mark like this. This is not reflexive. R2 clearly not reflexive. Why? In set A, 1 is there. 1, 1 is not there. R3, no. R4, no. These are not reflexive relations. Okay, come to this R5. Is R5 is a reflexive relation? Look here. Is it a reflexive relation? 1, 1, 2, 2 must present in the relation. In this, 2, 2 is not there. This is not reflexive. You observe, is it a reflexive relation? Is it a reflexive relation? No, this is not a reflexive relation. Observe this one. 1, 1, 2 comma 2. Is it is a reflexive relation? For every x belongs to A, x comma x belongs to the relation? Yes. 1 is there in set A. Order pair 1 comma 1 is there in this relation? Yes. I'll mark this one R7, right? This relation. You take 1 in set A, the order pair 1 comma 1 in the relation. You take 2 in set A, the order pair 2 comma 2 belongs to the relation. So R7 is a reflexive relation. So that's why I marked here. You can see R7, yellow color one. This is a reflexive relation. Like that, how many reflexive relations you must get? You must get 4 reflexive relations. Okay. You observe this R8. Is a reflexive? In this 1 comma 1 is not there. So this relation is not reflexive. You observe this R9. Is reflexive relation? Set A contains 1 comma 1 is not in this. So R9 is not reflexive. You observe this one, even though 2 comma 2 is there in this, 1 comma 1 does not belongs to this relation. That's why this is not reflexive relation. I hope you are all understanding. Now you see this one, 1 comma 1 is there, but 2 comma 2 is not there. Set A contains the element 2 na, 2 comma 2 must belongs to the relation. Then only we say it is reflexive. In R11, 2 comma 2 is not there. So this is not reflexive. R11 is not reflexive. You observe this R12, observe this R12, 1 is there in set A, 1 comma 1 is there in the relation, yes, 2 is there in set A, 2 comma 2 is there in the relation, yes, this relation is clearly reflexive relation, okay, for every x belongs to A, order pair x comma x belongs to the relation, then we say that relation is reflexive relation. Now you observe this R13, you observe this relation R13, you observe 1 comma 1 is there, 2 comma 2 is there. For every x belongs to A, the order pair x comma x belongs to the relation. That's why this relation is reflexive relation. This is reflexive. Till now we got 3 reflexive relations. What is the formula to calculate number of reflexive relations on A? This is the formula. 2 power n of A whole square minus n of A. That means we need to get 4 reflexive relations. Remember, every set, you will observe this. This is same as A cross A. Every set is subset to itself now. This is known as universal relation. Listen please. This is known as universal relation. And let me complete. Otherwise I am doing now. Observe this R14. In R14, it is not reflexive. Why? Because 1 comma 1 not in this relation. 1 comma 1 not in this relation. That's why R14 is not reflexive. Okay. Now you observe this R15. R15 is interesting one actually. Some people will argue that this is a reflexive relation, but this is not reflexive relation. Why? Because for every x belongs to A, x comma x belongs to this relation. You take 1 is there in set A. 1 comma 1 must belongs to the relation. So empty relation is not a reflexive relation. Now observe this one, R16. Is reflexive relation? In this 1 comma 1, 2 comma 2 are there? Yes, look here. 1 comma 1, 2 comma 2 present in this. So this relation is a reflexive relation. You can observe here, for 1 belongs to A, 1 comma 1 belongs to R. For 2 belongs to A, 2 comma 2 belongs to R. Therefore, this relation is reflexive relation. You can observe here, as per the formula, we are getting 4 reflexive relations. You see here, 1, 2, 3, 4. I hope you got clarity now. Which one is reflexive relation? Which one is not reflexive relation? I hope you got clarity. In case if you understand this, please drop a like and share this video with your friends and support our channel. Okay? Right. Now, number of reflexive relations is over. Identity relation. Here, many students will confuse between identity relation and reflexive relation. Difference between identity relation and reflexive relation. After this definition, I'll give that clarity. Okay, you see, identity relation. What is the definition of identity relation? You take A is any set. Then the relation R is a relation which contains order pairs A comma A such that A belongs to A. Try to understand. Reflexive relation definition is different. What is that? For every x belongs to A, the order pair x comma x belongs to R. Then we say this relation is reflexive relation. But here what they are saying, in this A is any set. You take one set A and the relation which is like this, that relation is called identity relation. And identity relation on set A is denoted by IA, capital IA. Okay, I'll try to explain this with an example so that you will get more clarity. I'll take one example here. Set A equal to 1, 2, 3. 3 elements I'll take. You know A cross A contains 9 elements. I am not writing A cross A. Please listen. You can understand. I am not writing A cross A. I'll take one relation on A. You need to identify is that relation is identity relation or not. Okay, 1 comma 1, 2 comma 2, 3 comma 3. This is the relation, and you can observe all the elements are I chosen from 1 to 3 only. So obviously this is the relation on A only. Okay, this is R is a subset of A cross A only. Now my question is this relation is identity relation or not? Yes, it is an identity relation that as per the definition. It contains order pairs A comma A. You observe here, the relation contains order pair A comma A. The relation contains order pairs A comma A. Identity they mention. Suppose your identity card is there, man. Your face on your identity card also same photo will be there. Right? What image you have, same image will be there on your identity card. Okay. You take an element A, again A will be there. It's identity. It's identity. If you take 1, yes, again 1 will be there. You take 2, again 2 will be there. If you take 3, again 3 will be there. Then only this relation is identity relation. This is identity relation. And I'll take one more example. You do not confuse. Look here, I'll take this as R1. I'll name it as R2. I'll take one more relation on this set. I'll take 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 3. Clearly this is a relation on A because all the elements I chosen from 1 to 3 only. Clearly this is a relation on A. Now my question is R2 is identity relation? Is R2 is identity relation? Here all your doubts will be clear. Is R2 is identity relation? No. Why? 1 comma 1 is there, 2 comma 2 is there, 3 comma 3 is there. Still why I am saying R2 is not an identity relation? Because you look here. This fellow came with fake identity. 1 is there here, but on his identity card number 3 is there. Okay. Actually, the person 1, but on his identity card third person name is there. This relation contains order pairs A comma A. If anything comes like this is not an identity relation. I hope you got the point here. This is identity relation. Identity. This is identity relation. What about this one? This one is not a identity relation. This is not a identity relation. I hope you understand this. This is not a identity relation. Okay. Here, difference between identity relation and reflexive relation. You observe, is this is a identity relation? Yes, it is a identity relation. Is this relation is reflexive? R1 is reflexive relation. For every x belongs to A, the order pair x comma x belongs to the relation. You look here, 1, 1 comma 1, 2, 2 comma 2, 3, 3 comma 3. Yes, R1 is reflexive relation. R1 is identity relation also. When it comes to R2, is it is an identity relation? No, this is not an identity relation because of this element. Now my question is R2 is reflexive? Is R2 is reflexive? Yes, R2 is reflexive. Till now we discussed that only now. R2 is reflexive. What the point? For every x belongs to A, the order pair x comma x belongs to this relation or not. That much only we will check. 1 comma 1 is there in the relation, 2 comma 2 is there in the relation, 3 comma 3 is there in the relation. That much only. I don't want 1 comma 3 is there, 3 comma 1 is there. I don't want that. For every x belongs to A, x comma x belongs to the relation or not. Yes, R2 is reflexive relation, but R2 is not a identity relation. I hope you understand difference between these two. Right? Identity relation. This relation contains order pairs which are in this form only, A comma A, B comma B, C comma C, like that only. Here, this is not in the form of A comma A. For the 1, right? For 1, it must be 1 year in identity relation. Okay. I hope you understand this point. I just want to a few points related to this identity relation. Identity relation on set A is always reflexive. Identity, I'll write here note point. This is note point. Identity relation on set A is always reflexive. Identity relation is always reflexive. But converse need not be true. But the converse need not be true means, but every reflexive relation need not be identity relation. Need not be identity relation. I hope you understand this. Best example is this one. This is equivalence relation. This is reflexive relation. This reflexive relation, but not identity relation. You observe here, this is identity relation. Every identity relation on set A is always reflexive. Okay, I hope you got this point. Symmetric relation. Right. See this symmetric relation. What is the definition of symmetric relation? A relation R on set A is said to be symmetric relation. A relation R on set A is said to be symmetric relation if for every order pair x comma y belongs to R, y comma x also belongs to R. Then we say that relation is symmetric relation. When we say the relation is symmetric relation, a relation R on set A. First of all, R is a relation on set A. R is a relation on set A. This relation is said to be symmetric relation. This relation is said to be symmetric relation when for every order pair x comma y belongs to R, if y comma x also belongs to the relation, then we say that that relation is symmetric relation. That relation is symmetric relation. I'll try to explain this by taking good example. Okay, I'll take what example to take? Set A. Set A is like this: 1, 2, 3. Okay. Now, no need to write A cross A here. I don't want to write A cross A. A cross A contains 9 elements. You know, I just want to write one relation on A. I want to write one relation on A. Okay. Okay. One relation on set A. Now, what type of relation I need to take here? I'll take 1, 2, 2, 1, and taken some examples here. 2, 2, 3. I taken like this. Now the question is it is a relation on A? Is it is a subset of A cross A? You can look, all the elements are 1, 2, 3 only. So obviously, definitely this will be relation on A only. If you want, you just calculate A cross A and you check all the elements will present in A cross A. Right. First thing. Now my question is this relation is symmetric relation? When we say a relation is symmetric relation, first you take one order pair x comma y. This is important, I'll mark. For every is there in this also. First you take one order pair x comma y in the relation and you check that the order pair y comma x belongs to the same relation or not. You just check it. For example, you look here, 1, 2 present in the relation. X comma y, y comma x. You look here, x comma y, y comma x, reverse order. 1, 2 is there in this relation. 2, 1 is present in this relation or not, you need to check. Check it. 2, 1 is there in this relation. Yes, it is there. 1, 2, 2, 1, both are present in this. From that, can I say that this relation is this relation is symmetric relation? No. You need to check like that for every order pair in the relation. For every order pair in the relation, you need to check. You taken 1, 2 na. 2, 1 is there means you cannot say 1, 2 you take. 2, 1 is there. Yes, very good. That means this element passed symmetric relation. Now you need to check for this element 2, 1. What is the reverse order? Reverse order of 2, 1 is 1, 2. Yes, 1, 2 is present. That means that this also passed symmetric relation condition. Now you look this third element 2, 3. For the element 2, 3, the element 3, 2 is there in the relation. When x, y belongs to R, y, x must belongs to the relation. Here 2, 3 is there in this relation. I am asking you that 3, 2 is there in this relation. Check it. No, 3, 2 is not there in this relation. Therefore, this relation is not symmetric. The main point is look here. For every order pair in the relation, for every order pair x, y in the relation, you need to check y, x belongs to that relation or not. Okay. This is not symmetric. What is the reason? The reason is like this. The order pair 2, 3 present in the relation, but the order pair 3, 2 does not belongs to the relation. 3, 2 is not in this relation. Because of this reason, we can say that this is not symmetric. Good. Now I'll take one more example. I'll name this as R1 and I'll take one more example. There you will get more clarity in this. Okay, R2 like this: 1, 1, 1, 3, 2, 2, 3, 3, 1. I taken like, I consider one relation. First point is this is a relation on A. You can look here, all the elements are 1, 2, 3 only. So definitely this is a relation on A. Now question is this relation is symmetric relation or not? When we say a relation is symmetric relation, for every order pair x, y, if y, x also belongs to the relation, then this relation is called symmetric relation. Okay. You look here 1, 1. 1, 1 reverse order is what? 1, 1 only. So for such type of elements, no need to check symmetric property. Right? This always satisfies symmetric property. 1, 1 reverse order is what? 1, 1 reverse order 1, 1 only. So no need to check symmetric property for this. 1, 1 reverse order 1, 1. 1, 1 is present in this relation. That means this element passes the symmetric relation condition. Okay. You take the element 1, 3, come to next element 1, 3. What is reverse order of this? Reverse order of this is 3, 1. 3, 1 present in the relation. Yes. That means this element passes this symmetric condition. Okay. 2, 2. I said na, for the elements like 1, 1, 2, 2, 3, 3, no need to check the symmetric property. They always satisfies. 2, 2 reverse order 2, 2. That is already present now. Good. Now come to this one 3, 1. For what is the reverse order of this 3, 1? 1, 3. 1, 3 present in the relation. Yes. That means what? For every order pair in the relation, for every order pair x, y in the relation, y, x also belongs to the relation. This reverse, you see, this x, y, x is there. 1, 3, 3, 1 is there. 2, 2, 2, is there. 3, 1, 1, 3 is there. So this relation is symmetric relation. How to say this? for every order pair x comma y in this relation, for every order pair x comma y in this relation, you can easily say that y comma x also belongs to the relation. So this relation R2 is symmetric. I am taking this examples in such a way that you can understand these definitions easily. Okay, so symmetric relation is also over. Next, related to symmetric relation, I'll take one more relation so that all your doubts will be clear. I'll take one relation like this: 1 comma 1, 2 comma 2, 3 comma 3. Okay, now the point is this relation on this set symmetric or not? You look here, 1 comma 1, this always satisfies symmetric property condition. 2 comma 2 always satisfies symmetric property condition because x comma y comma x both are 2 comma 2 only for this. 3 comma 3 reverse order is there. So here the point is this is an identity relation on A? Is this is an identity relation on A? Yes, identity relation is always symmetric. Just now I explained now what is identity relation. Identity relation is always symmetric. I hope you got the point. Okay, identity relation is always symmetric. Okay, good. So now the point is it symmetric or not? Yes, this relation is symmetric. This implies R3 is symmetric. What is the reason means what you will say? This is the reason. For every x comma y belongs to R, y comma x also belongs to the relation. That's why this relation is symmetric relation. Good. Very good, Pankaj. Now, related to symmetric relation, I given some examples. I hope you understand this example. Now, number of symmetric relations. Number of symmetric relation. Look here. Number of symmetric relation on set A. How many symmetric relations we can form on set A? What is the formula? 2 power n of A whole square plus n of A whole divided by 2. Okay, so this is the formula to calculate number of symmetric relations on a set A. Okay, here I taken one example. This set contains how many elements? This set contains 2 elements. So on this set, how many symmetric relations I can form on set? How many symmetric relations I can form? For that, what I'll do, I'll take one example here. Here this set contains 2 elements now. Number of symmetric relations, I'll write here, I'll calculate 2 power n of A whole square. N of A is 2. 2 square, that is 4, plus 2 divided by 2, that is 2 power 4 plus 2, 6. 6 by 2 is 3. 2 cube, 8. That means when I take set A like this, A cross A contains 4 elements. Number of relations on A formula. Number of relations on A formula is 2 power number of elements in A cross A. That is 2 power number of elements in A cross A in this example is 4. 2 power 4 is 16. Total 16 relations we can form on set A. All the 16 relations I can write. I already written here. Now in these 16 relations, how many relations must be symmetric? As per this formula, 8 relations must be symmetric, right? As per this formula, 8 relations must be symmetric. Okay, now I need to identify what are those symmetric relations. Okay, first one, look here, this one R1. Is a symmetric relation? Yes, it is a symmetric relation. Yes, it is a symmetric relation. Why it is a symmetric relation? I said for the, see, this element satisfies symmetric condition. Yes, this element satisfies symmetric condition. When we say a relation is symmetric relation, you take order pair A comma B. You take order pair x comma y. Y comma x is there in that relation or not? You need to check. You see, this type of elements always satisfy symmetric condition. So R1 is what? R1 is symmetric relation. Total 8 relations you will get. 8 symmetric relations you will get. Second one, you observe this relation. Order pair 1 comma 2 is there in this relation. Order pair 2 comma 1 is there in this relation. Order pair 2 comma 1 is not in this relation. Order pair 2 comma 1 not in this relation. That's why this is not symmetric relation. R2 is not symmetric. What about R3? 2 comma 1 is there. 1 comma 2 not in this relation. That's why R3 is not symmetric. What about this R4? Is R4 is symmetric? This type of elements 2 comma 2, 3 comma 3, this type of elements always satisfy symmetric condition. So here this is symmetric relation. This is a symmetric relation. I got 2 relations which are symmetric. Like this, I need to get total 8 symmetric relations. Now look this R5. 1 comma 1. Yes, this element satisfies the condition of symmetric property. Okay. Now look here, 1 comma 2 is there. 2 comma 1 present in this R5? No. So this relation is not symmetric. This relation is not symmetric. You look, what about this R6? 2 comma 1 is there, but 1 comma 2 not in this relation. So R2 is not symmetric. You look R7, look R7, important one, R7, look here. Is it is symmetric relation? Is it is symmetric relation? Take 1, 1. Reverse order 1, 1 is there. This type of elements always satisfy symmetric condition. Look here. This also satisfies symmetric condition, right? So R7 is a symmetric relation because for every order pair x comma y, y comma x also belongs to the relation. 1, 1 reverse order is 1, 1. 2, 2 reverse order is 2, 2. So R7 is a reflexive relation. Total 8 reflexive relations you need to find. Already we got 3 reflexive relations. Okay. Now you look this one, 1, 2, 2, 1. First you take 1, 2. What is the reverse order of 1, 2? 2, 1. 2, 1 present in this relation. Look here. Yes, 2, 1 present in this relation. Okay. So this element passes symmetric condition. Now you take 2, 1. Take 2, 1. 2, 1 reverse order is what? 2, 1 reverse order is 1, 2. Yes, 1, 2 is present. So this relation, which relation? R8. R8 is clearly symmetric relation. For every x comma y belongs to R, y comma x also belongs to this relation. Right, good. Now you see this R9, 1, 2 present in R9. 2, 1 present in R9? No, 2, 1 is not present in R9. See, I know that these things takes time to explain, but you will get clear clarity. Which one is a symmetric relation, which one is not symmetric relation, like that you will get clear clarity. That's why even though it takes time, I am explaining all this. Now you look for R10. 2, 1 is there. For that, 1, 2 is there in this relation? No, R10 is not a symmetric relation. What about this R11? You just check it. R11. Very good, Pankaj. You are actively participating. 1, 1. This satisfies symmetric condition. 1, 1 satisfies symmetric condition. Very good. 1, 1 reverse order 1, 1 only. Okay. You take this element 1, 2. 1, 2 reverse order is 2, 1. It is present. Okay. You take this order pair 2, 1. 1, 2 present. Yes, present. That means what happened? In this relation R11, for every x comma y belongs to this relation, y comma x also present in this relation. That's why this relation is a symmetric relation. Actually, total how many relations you need to get? 8 symmetric relations you need to get. I already got 5 symmetric relations. Okay. Now, listen carefully, please. This one, R12. 1, 2 present in this relation. In R12, 1, 2 is present. 2, 1 present in this relation? No. 2, 1 does not belong to this relation. Therefore, this relation is not symmetric. This is not symmetric. Okay. R13. In this 2, 1 is there. In R13, 2, 1 is there. 1, 2 present. 1, 2 present. No. 1, 2 not present in R13. So, R13 is not symmetric. Now, what about R14? Look here, R14. 1, 2 is there. Its reverse order is 2, 1. 2, 1 is there in this relation. Yes, 2, 1 is there in this relation. Good. This element passes symmetric condition. Now come to the second element. 2, 1. 2, 1 reverse order is 1, 2. Yes, this element also passes symmetric condition. Now you took here 2, 2. This type of elements always satisfy symmetric condition. Right? So R14 is what? Clearly, it's a symmetric relation. Clearly, it is a symmetric relation. How many symmetric relations I got till now? 1, 2, 3, 4, 5, 6. But actually, how many relations I need to get? I need to get 8 relations. Till now, I got 6 relations only. Here is the point. Here is the key point. Please listen carefully. R15. You look here. R15, is a symmetric relation or not? First point, what is the symmetric relation definition? For every order pair x comma y, y comma x also belongs to the relation, then we say that relation is symmetric relation. When it comes to this R15, in this there is no order pair first of all. If a comma b is there in this relation, if x comma y is there in this relation, then we look for y comma x. Got the point? If x comma y present in this relation, then we will check for y comma x. In this x comma y is not there first of all. So here we will consider that R15, that means empty relation. This relation is known as void relation, empty relation. Last class we discussed. Empty relation is a symmetric relation. This is the key point. See, this is the benefit of doing like this. See, total number of symmetric relations 8. I am trying to find what are those 8 symmetric relations for this example. Here important point is R15, empty relation. This is the relation. It is a subset of A cross A. This relation is a symmetric relation. Keep this point. Note this point. Symmetric relation. Empty relation is a symmetric relation. Okay. And you look this R16. Every set is subset to itself. 16 is a symmetric relation. Look here, 1, 1. This order pair always satisfies symmetric condition. Now you take next order pair, 1, 2. For this 2 comma 1 present in this relation? Yes, present. Now this element passes symmetric condition. Now come to the next element. Like that you need to check for every order pair in the relation. 2 comma 1 reverse order, 1 comma 2, yes, present. Now 2 comma 2, obviously this 2 comma 2 satisfies symmetric condition. So R15 and R16, these you can look here. Total how many we got? Total 8 relations we got. You can count 1, 2, 3, 4, 5, 6, 7, 8. 8 symmetric relations. So what you learn in this, you learn number of symmetric relations formula, and you are able to check now. Here 16 relations you taken, and in all 16 relations you checked whether this relation is symmetric or not, like that. I hope you got clarity about symmetric relation. Now you won't get any doubts in the symmetric relation, right? Good. Now transitive relation. What is transitive relation? See, in these three relations, these three are like heroes. Reflexive relation, symmetric relation, transitive relation. If you understand the definition of reflexive relation, symmetric relation, transitive relation, you will become hero of this chapter, right? That means that much easy. These relations will be that much easy. Okay, look here. R is a relation on A. First thing, R is a relation on A. Okay, the relation is said to be transitive relation. When we say that relation is transitive relation, you look here. For every x comma y, y comma x belongs to relation. For every, that is also important. For every, in this x comma y, y comma z, what is very important? Look here. Here y is there. Here also y is there. Look here. This order pair x comma y and y comma z. If the relation contains x comma y and y comma z, look here. This order pair ends with y. This order pair starts with y. If such type of order pairs exist in the relation, for every such pair of order pairs, look here, for every such pair of order pairs exist in the relation, if exist, then we look for x comma z present in the relation or not. I hope you understand this point. Whenever such type of order pair exists in the relation, then you look here, x comma z. X comma z present in that relation or not, I'll check. This relation is this normal R actually. This is real number R came here. Right. Okay, good. I hope you understand this. Good. Right. Now, I'll take examples, very good examples I'll take to explain this transitive relation. Afterwards, you will never say that transitive relation is confusing one. Many students will confuse in this transitive relation. Actually, transitive relation is very easy. Okay, transitive relation problems I need to take. Okay, I'll take one example. First set A, I'll take set A elements like this 1, 2, 3. Okay, now I'll consider one relation on set A. I'll check that relation is transitive relation or not. 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 2, 2 comma. This relation is a relation on A. You can look all the elements I taken from set A. All the elements are like 1, 2, 3. So definitely this is a relation on A. No doubt in that. This is a relation on A. My question is this relation is transitive relation or not? See, directly I can pick an example. I can say because of this condition, this is not transitive relation. But generally, how to check transitive relation? To avoid unnecessary confusion, how to check transitive relation? Listen this carefully. Here, first I'll take one order pair. First, you take one order pair. Okay. Here, this order pair ends with 1. This order pair ends with 1. Now you look for the order pair which starts with 1. You look for the remaining order pairs in this relation which starts with 1. Look here. This is the order pair starts with 1. That means now you are able to find x comma y, y comma z in this relation. You are able to find x comma y, y comma z in this relation. What is x comma z? X comma z is 1 comma 2. X comma z is 1 comma 2. So 1 comma 1, 1 comma 2. For this a comma c is 1 comma 2. 1 comma 2 belongs to this relation. Yes, here it is there. Now 1 comma 2 is there now. That means when I take this element, that means the element ends with 1. This is the only one starts with 1. So for these two elements I checked transitive relation. This satisfies transitive relation. Now from this we cannot say that it is a transitive relation. You need to check like that. See, directly I can say this is not transitive relation. I know how to prove it, but I am making the thing that how to check. Don't go with rough random methods. General method, how to check. You won't mistake anything in this method. You look here. Next you take the second order pair 2 comma 2. Second order pair 2 comma 2. It ends with the 2 na. It ends with the 2 na. You look for any other order pair is there in this which starts with the 2. Yes, here it is. That means you are able to find x comma y, y comma z You are able to find x comma y, y comma z. For that, what is x comma z? Look here, x comma z is 2 comma 3. X comma z is 2 comma 3. Now you look, 2 comma 3 is there in this relation. Yes, 2 comma 3 is there in this relation. So this is also over. Now come to this element. This ends with 3 now. You look for other order pairs which starts with 3. Is there any other order pair which starts with 3? No. That means this element passes here, transitive relation. Now look here. This is 1 comma 2. It ends with 2 now. Any other order pair which starts with 2? Any other order pair which starts with 2? Look here. This is the order pair starts with 2. So this is first element. This is second element. X comma y. Next y comma z. For x comma y, y comma z, what is x comma z here? The x comma z is 1 comma 2. Now in this order pair 1 comma 2 is there. Yes, here it is there 1 comma 2. Okay, this is also over. Now last one. You look here, 2 comma 3. This ends with 3 now. This ends with 3 now. No, I think I not checked for this one. No. 1 minute please. This one I not checked for this element, I think. 1 comma 2. 1 comma 2. This element ends with 2. You look for the elements which starts with 2. This starts with 2. I checked for that, and you look, this also starts with 2. This also starts with 2. Okay, 1 comma 2, 2 comma 3. That means you are able to find x comma y, y comma z. Okay, now you need to look for these two order pairs, x comma z belongs to the relation or not. Look here. 1 comma 3, x comma z means 1 comma 3. 1 comma 3 present in this relation. 1 comma 3 present in this relation. 1 comma 3, 1 comma 3 not there. Because of that reason, this relation is not transitive relation. See, directly I can explain in the beginning only. 1 comma 2, 2 comma 3, you take 1 comma 3 does not belongs to this relation. But actual method is checking each and every element is the best method, right? Right, good. Okay, what I can say here, this relation is not transitive, relation. Why this relation is not transitive relation? Because 1 comma 2, 2 comma 3, we are able to identify both. 1 comma 2 belongs to the relation 1 comma 2 and 2 comma 3. You are able to identify x comma y, y comma z in the relation, right? But x comma z does not belongs to the relation. What is x comma z here? 1 comma 3. 1 comma 3 present in this relation? No. 1 comma 3 does not belongs to the relation. Therefore, this relation is not transitive. This relation is not transitive. I hope you understand. Okay. I'll take one more best example so that you can understand very easily. What is this? Your doubts will be clear with this example. I'll take something like this. R2. 1 comma 2, 1 minute. 1 comma 2, 1 comma 2, 2 comma 3. And 1 comma 3. I taken one relation like. First point is it is a relation on A. You can look, all the elements are 1, 2, 3 only. All the elements are 1, 2, 3. Definitely this will be relation on A. Now my question is this relation is transitive relation or not? Is this relation is transitive relation or not? You look here 1 comma. How to check transitive relation or not? You take this 1 comma 2. It ends with 2 now. You look for the order pairs which starts with 2. You look for the order pairs which starts with 2. Here this is there. 1 comma 2. 1 comma 2, 2 comma 3. 1 comma 2, 2 comma 3. That means you are able to find x comma y, y comma z. You need to look for x comma z belongs to the relation or not. X comma y, y comma z belongs to, or what is x comma z? X comma z is 1 comma 3. 1 comma 3 present in this relation? Yes. Now you take this one. This ends with 3. Now look for other order pairs in this relation which starts with 3. You look for other order pairs in this relation which starts with 3. No other order pair starts with 3. So no problem. Now come to this 1 comma 3. 1 comma 3. It ends with 3. Is there any other order pair starts with 3? Is there any other order pair which starts with 3? No. That means it's okay. It's okay. That means what? In this, for every x comma y, y comma z belongs to R. X comma z also belongs to R. Important thing is, you are able to identify such pair in this relation for all such pair. That is important for every such pair. Okay. So what the point here is, this relation is transitive relation or not? Yes, this relation is transitive relation. This relation is a transitive relation. Good. Now I'm taking so much of time, but this topic is like that only. If I explain hurriedly, later you will confuse. No satisfaction to you, no satisfaction to me also. Now R3. R3. What is R3? I do one thing. I'll take one separate example to clear all your doubts. Suppose set A is like this. Set A is like this. 1, 2, 3, 4. Set A is like this. 1, 2, 3, 4. I'll consider one relation on this set. I'll consider one relation on this set. Okay, R equal to, how to consider here the relation 1 comma 2. Okay, 1 comma 2, listen this carefully, this is important. 1 comma 3 comma 4, 1 comma 4, 1 comma 2, 3 comma 4, 1 comma 4. I taken like this. Now you can look, is it is a relation on A? All the elements are taken from 1, 2, 3, 4, these elements only. So this is a relation on this set. Now my question is this relation is trans to relation or not? Listen this carefully. Is this relation is trans to relation or not? How to check trans to relation? You need to look for pair x comma y comma z in the relation. How to look that? Now take here 1 comma 2 is there. This ends with 2. This ends with 2. Now you look that any other order pair starts with 2. No other order pair starts with 2. Look here. No other order pair starts with 2. Okay, no problem. Now you take the second element. It ends with 4. Now you look that any other order pair starts with 4. Any other order pair starts with 4? No. Okay. Now you look here. This order pair ends with 4. Is there any other order pair which starts with 4? No, right? So when you are able to find such a pair, then only we look for x comma z. But what happened in this relation? You are not able to find x comma y comma z. You are not able to find x comma y comma z in the relation. Then why to check for x comma z? In this case, we say that this relation is trans to relation. It is important. You may confuse, but you need to consider it as a trans to relation. That is what this definition is saying. When you can find such pair x comma y comma z in the relation, then you look for x comma z. Now you look here, x comma y comma z does not exist in this relation. X comma y comma z does not exist in this relation. Then how you can say this relation? Then what we say, x comma y comma z does not exist. Then how you will check for x comma z? In such case, we say that this relation is trans to relation, is a transitive relation. Okay, this is trans to relation. Good. So I hope you understand what is a reflexive relation, what is symmetric relation, what is trans to relation. Next definition, equivalence relation. What is equivalence relation? What is equivalence relation? A relation R on A is said to be equivalence relation. A relation R on set A is said to be equivalence relation if R is reflexive, R is symmetric, R is transitive. When the relation is reflexive, when the relation is symmetric, when the relation is transitive. In such case, if R is a reflexive relation, symmetric relation, when R satisfies all three conditions, then we say that that relation is equivalence relation. Here, to explain this, I'll take one example. I'll take set A. Set A is 1, 2, 3. Okay, 1, 2, 3. Now I'll consider one relation here. That relation is like this: 1 comma 1, 2 comma 2, 3 comma 3, 1 comma 3, 3 comma 1. First point, is it is a relation on A? Is it is a relation on A? You can look here. All these elements are 1, 2, 1, 2, 1, 1, 2, 3. I taken all the elements from set A. Definitely this will be relation on A. Now my question is this relation is reflexive relation? What is the definition of reflexive relation? For every x belongs to A, x comma x also belongs to the relation, then we say that that relation is reflexive relation. 1 is there in set A, the order pair 1 comma 1 belongs to relation? Yes. 2 is there in set A, the order pair 2 comma 2 belongs to the relation? Yes, the order pair 2 comma 2 belongs to relation. For 3 belongs to set A, 3 comma 3 belongs to relation? Yes. This relation is reflexive relation. This relation is reflexive relation. First condition is holds good. First condition holds good. This relation is reflexive relation. Now, is this relation is symmetric relation? Is this relation is symmetric relation? How to check? For every order pair we will check. Now here 1 comma 1 is there. This type of elements always satisfy symmetric condition. Reverse order of 1 comma 1 is 1 comma 1 only. Okay, you look here, 2 comma 2. Reverse order of 2 comma 2 is 2 comma 2 only. This type of elements always satisfy symmetric condition that I already discussed. Now only you need to look for these two elements. 1 comma 3, reverse order is 3 comma 1. Okay. 3 comma 1, reverse order is 1 comma 3. Good. So this relation is clearly symmetric relation, because whatever x comma y you take, its reverse order y comma x also present in this relation. That's why this relation is symmetric relation. Okay. This relation is reflexive, this relation is symmetric. Now I need to check, is this relation is transitive or not? How to check? Here 1 comma 1. Any other starts with 1? Yes, here this starts with 1. 1 comma 1, 1 comma 3. 1 comma 1, 1 comma 3. What is x comma z? 1 comma 3. 1 comma 3 belongs to this relation. Look here, 1 comma 3 belongs to this relation. Now you take this one. This ends with 2. Any other starts with 2? Look here, any other order pair starts with 2? No other order pair starts with 2. So need not to worry. You look here, this order pair ends with 3. Any other order pair starts with 3? Look here, this is 3 comma 1. Okay. 3 comma 1, sorry, 3 comma 3, 3 comma 1. What is x comma z? X comma z is 3 comma 1. 3 comma 1 belongs to this relation. Look here, 3 comma 1 is belongs to this relation. Now you come to this one. This ends with 3. This ends with 3. Any other relation starts with 3? Yes, this starts with 3. 1 comma 3, 3 comma 1. What is x comma z? X comma z is 1 comma 1. 1 comma 1 is there in this relation? Yes, it is there. Now you take this one, 3 comma 1. It ends with 1. You look that any other order pair starts with 1 here. This starts with 1. 3 comma 1, 1 comma 3 is 3 comma 1. That means x comma z is 3 comma 1. 3 comma 1 belongs this relation. So this relation is satisfying transitive condition also. So R is therefore R is reflexive, R is reflexive, R is symmetric, and R is transitive also. This relation is transitive also. R is reflexive, R is symmetric, R is transitive. When a relation satisfies all three conditions, then R is equivalence relation. R is a equivalence relation. I hope you understand. You see, this is the question given in JEE examination 2025. The question is the number of non-empty equivalence relations on a set. Number of equivalence relations on this set, non-empty. However, as set 1, 2, 3 is there, equivalence relation means it must be reflexive, symmetric, transitive. Empty set is not a reflexive relation. So this question we can take it as a number of equivalence relations also. To find number of equivalence relation, we have one trick. That number of equivalence relations we can find out from Bell's triangle. What is Bell's triangle? In Bell's triangle, first we'll write 1. Below to this one, you write one more 1. Okay, first you write like, now you add these two. 1 plus 1 is 2. You write that 2 here. Now whatever the last number you got, you write that number here. Now you add these two. 2 plus 1 is 3. Now add these two. 3 plus 2 is 5. Now whatever the last number you got, that write that number here. Okay, 5. Now you add these two. 5 plus 2 is 7. Now add these two. 7 plus 3 is 10. Now you add these two. 10 plus 5 is 15. Okay. This process will continue. For example, here last number is 15 is there. Na? You write 15 here. 15 plus 5, 20. 20 plus 7, 27. 27 plus 10, 37. 37 plus 15, 52. Here you observe this last element. From this only we will get number of equivalence relations. When set A contains one element, then number of equivalence relations is equal to 1. If set A contains two elements, then number of equivalence relations on that particular set is 2. Two equivalence relations can be formed. If set A contains 3 elements, number of equivalence relations is 5. Right? You observe this question. Here there are 3 elements are there. So number of equivalence relations is what? 5. So what is the right option? Third option is the right option. Very easy question, time saving question in JEE level. But only the thing is, to find number of equivalence relations, you must know about Bell's triangle. If set A contains 4 elements, number of equivalence relations equal to 15. If set A contains 5 elements, number of equivalence relations is 52. Like this, if we continue, whatever the number of elements are there in the given set, based on that, we can say number of equivalence relations. I hope you understand this solution. So this class is all about what we learned. I just quickly go through these points. Next problems are there. That's why when we say a relation is reflexive relation, for every x belongs to A, the order pair x comma x belongs to the relation, then that relation is called reflexive relation. And I explained with an example. And number of reflexive relations formula, you need to memorize this formula in object 2. In JEE they'll give how many number of reflexive relation we can form on set A. The formula is 2 power n of A whole square minus n of A. That also explained with examples. Next, you learn what is identity relation. Identity relation, all order pairs must be like this only, and you learn the difference between identity relation and reflexive relation. Next, you learn what is symmetric relation. For every order pair x comma y belongs to R, y comma x also belongs to the relation, then we say that that relation is symmetric relation. Next, you learn number of symmetric relations formula. Number of symmetric relation formula is what? 2 power n of A whole square plus n of A divided by 2. That I explained by taking with some examples. Okay. Next, you learn transitive relation definition. When x comma y comma z exist in the relation, then only we look for x comma z. If x comma z belongs to R, then we say that relation is transitive. Otherwise, we say that it is not transitive. When you are unable to identify x comma y comma z in the relation, in such case also we say that that relation is transitive relation. Good. Now, equivalence relation. A relation is reflexive, symmetric, transitive, then that relation is called equivalence relation. Okay. I'll show you quickly what are the things we are doing in today's class. This is the one problem, and number of reflexive relations. You see, identifying which relation is satisfying the given condition, and you see which given relation is reflexive or symmetric or transitive. You can observe by doing these problems, you will get grip on these definitions. Reflexive relation, symmetric relation, transitive relation definitions are there. Okay. You observe this question number 6, what they are asking in this question. They given one relation, seems to be little lengthy relation. Okay, this is the relation on set A. Set A is given here, 3, 6, 9, 12. Now, the relation is what? Reflexive, symmetric, transitive, that type of things are there in this. As this set A contains 3, 6, 9, 12. Look here, the set contains 3, 6, 9, 12. Na? 3, 3, 6, 6, 9, 9, 12, 12 must present in the given relation. We will check for those things. 3, 3 is there. Yes. 6, 6 is there. 9, 9 is there. 12, 12 is there. So easily we can say that this relation is reflexive relation. Unfortunately, we cannot strike off any option here. You look here, reflexive is there. In this also, when we say equivalence relation, it must be reflexive. There is a chance of this option also. Reflexive only, chance of this option, reflexive. So, okay, we cannot strike off any particular option at this point. Now, we need to check symmetric property. I already discussed in last class. See, these order pairs in the relation always satisfy symmetric property. No need to check separately. What is symmetric property? If x comma y belongs to the relation, then we look that y comma x also belongs to the relation or not. We will check for these things. Here, if you take 3, 3, what is the reverse order of 3, 3? That is 3, 3 only. So, for these 4 elements, you no need to check symmetric property. These 4 elements definitely satisfy symmetric law. These 4 elements definitely satisfy symmetric law. Okay. Now you need to check for these elements only. Look here, 6, 12 is there here. 6, 12 is there. If you start from here, take 6, 12. You look for 12, 6. 12, 6 belongs to this relation. Where is 12, 6? Nowhere. 12, 6 is not in this relation. So, what I'll say here, when it comes to reflexive, it is reflexive. I'll write the reflexive. It is reflexive. Okay. Symmetric. 6, 12 belongs to the relation, but 12, 6 does not belong to the relation. Because of this reason, we say that R is not symmetric. R is not symmetric. See, for every order pair, if A comma B belongs to the relation, then B comma A must belongs to the relation. Then only we say that that relation is symmetric. So this relation is not symmetric. So which options I can strike off here? You please look. I can strike off this option. This is not a equivalence relation. It cannot be equivalence relation because it is not symmetric. And reflexive, transitive, symmetric only. Option A also wrong option. If you strike off like this, sometimes it will be very easy to identify the option. Okay. So it is not symmetric. So it cannot be first option. It cannot be first option. It cannot be second option. Answer will be either third option or fourth option. For that, I need to check the transitive property. Here the tricky part is there in this. Listen this carefully. I'll tell you one easy method to how to check the transitive relation. Listen carefully. See, these elements are exceptional. While checking transitive relation, no need to consider these elements. While checking transitive relation, no need to take these elements. What is transitive relation? If x comma y and y comma z both are belongs to the relation, then we look that x comma z belongs to the relation or not. X comma y, y comma z. See, this order pair ends with y, this order pair starts with y. We need to take such an order pair x comma y, y comma z, then we look for x comma z belongs to the relation or not. Transitive relation, how to check? Listen this carefully. Transitive relation, how to check? Here, no need of these elements. Don't consider these elements while checking transitive property. I'll tell you why. That is also I'll tell you. First start with this element 6, 12. It ends with 12 na. You look that any other element in this order pair starts with 12. You take 6, 12. It ends with 12. Now you look for other order pair which starts with 12. This starts with 12, but I said na, you don't consider these 4 elements. Don't consider these 4 elements. Don't consider. Why? Because see here, in case if I consider what happened, something like this. Listen please. A comma B like B comma B. Listen carefully please. This is A comma B. And this is B comma B. Look here, A comma B, B comma B. When you take such type of order pair, obviously you are going to get A comma B. That is the first order pair. It will be in the relation. That's why no need to check I am saying. Okay. So here you take 6, 12. Any other order pair starts with 12. You don't consider these elements. You consider these elements. Any other order pair starts with 12? No. So no problem. This we verified for transitive property. Now you come to this one. It ends with 9. Any other order pair starts with 9? Don't consider these things. You look for these only. Any other order pair starts with 9? No. So need not to worry. We verified transitive relation for this also. Now this ends with 12. Now any other order pair starts with 12. Look here, any other order pair starts with 12? No. That means for this also transitive relation and transitive property verified. Now you look for this. This order pair, this is 3 comma 6. It ends with 6. Now you look that any other order pair starts with 6. You look here. Here it is there, 6 comma 12. 3 comma 6, 6 comma 12. I'll take here 3 comma 6, 3 comma 6 belongs to the relation, and 6 comma 12 also belongs to the relation. That means we are able to find A comma B, B comma C in the relation. If we can find A comma B, B comma C, then we look for A comma C. A comma C is what here? A comma C is 3 comma 12. 3 comma 12 is present in the relation? Yes. 3 comma 12 is present in the relation. Look here, 3 comma 12 present in the relation. So this implies 3 comma 12 belongs to the relation. I verified transitive property for all the elements, and I am saying that no need to check transitive property for these things. I hope you understand. Why I am saying, see, you take 3 comma 3, any other starts with 3, look here. 3 comma 3, 3 comma 9. This looks like A comma B, B comma C. If you take these type of things, A comma C obviously will present in this. You look here. A comma A comma B. You observe this. You observe these things. Ends with A, starts with A. A comma C is what? A comma C is A comma B. A comma B will be present in this. That's why no need to check. I hope you are getting this point. In case if you understand this, please drop a like and comment. Yes, I understand this transitive property. Right? Good. Now, so 3 comma 12 belongs to R. What I can say? I can say that the relation R is transitive. The relation R is transitive. So what happened? This relation is reflexive. This is reflexive. This is reflexive. Why? Because 3 comma 3, 6 comma 6, 9 comma 9, 12 comma 12 belongs to this relation. That's why this relation is reflexive. This relation is transitive. So in this option D is the right option. I hope you understand. Right? Very good. Now we'll move to next question. Look here. What is this question? Set A is like this. Set A is 1, 2, 3. Then what they are asking? Number of reflexive relations on set A. What is the formula? In last class we discussed number of reflexive relations. Number of reflexive relations. What is the formula? Number of reflexive relations. Formula 2 power n of A whole square minus n of A. This is number of reflexive relations formula. Here, look here, 2 power. How many elements are there in set A? 3 elements are there. 3 square. 3 square is what? 3 square is 9. 9 minus 3. That is what? 2 power 6. 2 power 6 is what? 64. So you can observe here 64 option is there. So third option is the right option. This is very easy problem if you memorize this formula. In case if you don't know this formula, then you may feel it is difficult. Right? So number of reflexive relations formula 2 power n of A whole square minus n of A. Okay. And in last class we learned number of symmetric relations formula also. Okay, good. Now you observe this one. 8th question. What they are given? They are saying that R is a relation from A to B. The relation R from A to B. Okay. What is set A given? What is set B given? And how the relation is defined, that is also given. R is set of all order pairs x comma y such that x is less than y, x belongs to A, y belongs to B. Then which one is correct? R is correct or R inverse is correct? We need to identify. Okay. Here the relation is what? Set of all order pairs, first element belongs to set A, second element belongs to set B such that x is less than y and R is a relation from A to B. When we say R is a relation from A to B, if R is a subset of A cross B, if R is a subset of A cross B, then we say that R is a relation from A to B. What I will do here, first I will calculate A cross B. Solution, first I will calculate A cross B. Okay. You can look here, set A is there, take 1 and you pair with all the elements of set B. What you will get? 1 comma 1, 1 comma 3, 1 comma 5. You write A cross B is 1 comma 1, 1 comma 3, 1 comma 5. Okay. Now you take the second element 2 and you pair with all the elements of this set. What you will get? 2 comma 1, 2 comma 3, 2 comma 5. Okay. 2 comma 1, 2 comma 1, 2 comma 3, 2 comma 5. Good. Now you take the third element and you pair with all the elements of this set. 3 comma 1, 3 comma 3, 3 comma 5. Okay, so 3 comma 1, 3 comma 3, 3 comma 5. So total, how many order pairs you will get? Set A contains 3 elements, set B contains 3 elements. Now A cross B contains 3 into 3, 9 elements. You look here, total 9 elements are there? Yes, 9 elements are there. Now, what type of relation it is? This is a relation which contains order pair x comma y such that x is less than y. You look here, is 1 is less than x? No, 1 is not less than x. 1 is not less than x. 1 equal to x. Now you observe this one. Is 1 is less than 3? Yes, 1 is less than 3. So this order pair comes to this relation. This relation contains what order pairs? This relation contains order pairs such that x less than y, x belongs to a, y belongs to b. Okay. Now you look for this 1 comma 5. Is 1 is less than 5? Yes, 1 is less than 5. 1 comma 5. Next, you look here. 2 is less than 1. No, 2 is greater than 1. So this order pair doesn't belongs to this relation. You look here 2 comma 3. Is 2 is less than 3? Yes, 2 is less than 3. So the order pair 2 comma 3 belongs to this relation. Look here 2 is less than 5. Yes, 2 is less than 5. So this order pair comes to this relation. 3 is less than 1. No. Which type of order pair we will get? Whenever x is less than y, then the order pair x comma y belongs to the relation. Okay, 2 comma 5 is also 1. Is 3 is less than 3? No. Look here. Is 3 is less than 5? Yes, 3 is less than 5. So this is what they need to give. This is what they need to give. Total how many elements are there? 5 elements are there. 1 comma 3, 1 comma 5, 2 comma 3. 1 comma 3, 1 comma 5, 2 comma 3. 2 comma 5, 3 comma 5. So easily we can say that first option is the right option for this, right? It is easy question. Just they given relation in set builder form. I written this relation in roster form. That's it. Okay, good. I hope you understand this. Now we'll move to next problem. You observe here, see these problems are very important to understand the concept. Here set A is like this 1, 2, 3, 4, 5. Okay. How the relation R is defined as the relation R contains set of all order pairs x comma y. X is less than y. X is less than y. Now you need to check reflexive. What they are asking, this relation is reflexive relation or symmetric relation or transfer relation. What type of relation it is, like that they are asking. Okay, this is a relation on this set. R is a relation on A. X comma y both are belongs to set A. Here very easy thing. Now is it is reflexive or not? Is it is reflexive or not? When I can say reflexive, this is set A na. If 1 comma 1 belongs to the relation, if 1 comma 1 belongs to the relation, then I say that this relation is reflexive. When 1 comma 1 belongs to R, see this relation contains all order pairs such that x is less than y. This relation contains all order pairs such that x is less than y. Now my question is 1 is less than 1? Is 1 is less than 1? No. 1 is not less than 1. Here 1 comma 1, not only 1 comma 1, 2 comma 2 also not belongs to the relation, because every number cannot be less than 2 itself. I hope you are understand. As 1 is there in set A, 1 comma 1 must present in this relation. 1 comma 1 does not belong to this relation. Because of this reason, I can say that this relation is not reflexive. This is not reflexive. It's not reflexive relation. Okay, not reflexive. Good. So that means what I can do here, it cannot be first option, it cannot be fourth option also. Now the answer is either second option or third option. Okay. Okay. Now what I'll check a symmetric condition. Symmetric. What is symmetric condition? You take one order pair x comma y belongs to the relation. You take one order pair x comma y belongs to the relation. You look that y comma x belongs to the relation or not. Here R is a relation on A na. R is a relation on A na. You can look here. The order pair 1 comma 3 belongs to this relation. 1 is less than 3. 1 is there in set A. 3 is also there in set A. You need to know good knowledge about these relations. Especially last class you check those videos. Here 1 comma 3 belongs to the relation. Correct? Why 1 comma 3 belongs to the relation? 1, 3 both are in set A and 1 is less than 3. That's why the order pair 1 comma 3 belongs to the relation. Yes, it is clear 1 comma 3 belongs to the relation. Now you look that 3 comma 1 belongs to this relation or not. When 3 comma 1 belongs to the relation, both are from set A. Okay. Now you look that is 3 is less than 1. Is 3 is less than 1? No. 3 is greater than 1. 3 is greater than 1. That means 3 comma 1 does not belongs to the relation. What is symmetric condition? For every order pair x comma y belongs to the relation, y comma x also must present in that relation. But here 1 comma 3 present in the relation, but 3 comma 1 does not belong to this relation. From this what I can say? I can say that this relation is not symmetric. Okay, this relation is not symmetric. When it is not symmetric, so what I can mark here? Second option is not possible. This relation is not symmetric. Obviously, what option is the right option? Third option is the right option. If you want to check, you can check as per general transitive relation x less than y given. You take x comma y belongs to the relation, suppose, and you suppose that y comma z also belongs to the relation. Now you need to look that x comma z belongs to the relation or not. That is what this transitive property is. Okay, if when x comma y belongs to the relation, when x is less than y, so here suppose x is less than y, x comma y belongs to R means x is less than y, y comma z belongs to R means y is less than z. See, x is less than y is less than z. What I can say? Can I say that x is less than z? Very simple here. Look here. 1 comma 3, 1 is less than 3, 3 comma 5, both are present in this relation. If you want, you can check. These both elements are there in set A, and you can see 1 is less than 3 and 3 is less than 5. Okay, 1 is less than 3, 3 is less than 5. Is 1 is less than 5? Yes, this condition holds good. Whenever x is less than y is less than z, with common sense, with common knowledge, we can say that x comma z belongs to the relation. We can say that order pair x comma z belongs to the relation, right? Order pair x comma z belongs to the relation. So obviously, however, we identified that these first three options are wrong options. Obviously, fourth option is right option. However, I explained why it is transitive also. Good. I hope you are all understanding these problems. You look here. What is this relation? A relation greater than is denoted by the set of all integers. On set of all integers. R is a relation on set of all integers. The question is, how this relation greater than means, I'll tell you here. I'll write in R is a relation which contains order pair x comma y such that x is greater than y and x comma y both are integers. This is what they given relation in set builder form. This is what they are giving in the question. Now we need to say that what type of relation it is, reflexive or symmetric or transitive. Okay, you look here. When we can say this relation is reflexive, relation. If integer 1 is an integer, 1 comma 1 belongs to the relation or not, you check. When 1 comma 1 belongs to R, when 1 is greater than 1, is 1 is greater than 1, 1 equal to 1, 1 cannot be greater than 1. Here easily we can say that 1 comma 1 does not belongs to R. Not only 1 comma 1, 2 comma 2 also does not belongs to R. Minus 1 comma minus 1 also does not belongs to R. Just to say it is not reflexive, one counter example is enough. To say it is not reflexive, one counter example is enough. Okay, 1 comma 1 does not belongs to R. So from this I can say that this relation is not reflexive. That's good. Right. Now next, not reflexive means you can look here. This relation is not reflexive. We can strike off this and you can strike off this also. Okay, you strike off like this so that getting answer will be very easy. Okay, so next I'll check for symmetric condition. What is symmetric condition? Symmetric condition, suppose x comma y belongs to the relation. You suppose x comma y belongs to the relation. Then we look that y comma x also belongs to the relation or not. If y comma x belongs to the relation, then we say it is symmetric. If you can find one example, one order pair x comma y belongs to the relation, but y comma x does not belong to the relation, then we can say it is not symmetric. I'll take one example. 3 comma 4. X is greater than 5. I'll take 4 comma 3. 4 comma 3 I'll take. You take 4 comma 3 belongs to the relation. 4 comma 3 belongs to the relation. Very good. Now the point is 4 is greater than 3 or not? 4 is greater than 3? Yes, 4 is greater than 3. This is relation present in this. This is order pair present in this relation. This is the order pair present in this relation. Now my question is 3 comma 4 belongs to the relation. It is very clear this order pair is there in this relation because both are integers and x is greater than y. Now 3 comma 4 belongs to the relation or not? It must, to say it is symmetric, it must belongs to the relation. But 3 is, both are integers, but 3 is not greater than 4. 3 is not greater than 4. Because of this reason, I can say that this relation is not symmetric. See, to say it is not symmetric, give one example is enough. Give one example such that it is not symmetric. When you are saying it is not reflexive, if you can find one counter example, it is enough. Because of this reason, this is not symmetric. Okay. Because of this reason, this is not reflexive. You give one counter example to say not reflexive, not symmetric, not trans. Okay. As we are doing JEE problems, by this time, I hope you all know the basic things of this chapter: symmetric, reflexive relation, symmetric relation, transitive relation. However, I am trying to explain all the things in detail. In case if you're not good in definitions of reflexive relation, symmetric relation, transitive relation, please go back and check those. Okay, right. Now, see this question. What is this question? What they are saying, let A be the set of all children in a family. Set of all children. Set of all children means in this boys will be there, girls will be there, all will be there. Set of all children in a family. Okay. The relation x is a brother of y. X is a brother of y. Okay. Then the relation on set A, okay, is a what type of relation? Reflexive, symmetric, transitive, such type of things are given. Okay. So x is a brother of y. You look here. In this, you check that x comma x belongs to the relation. X comma x belongs to the relation or not? You check. X is what? X is a family member. X is a family member. X is set of all children in a family. X is some boy or girl. One person you take. You take x comma x Is it possible that x is a brother of x? Is it possible that x is a brother of x? X cannot be brother of x. X cannot be brother of x. So what we say? This is not reflexive. This relation is not reflexive. Okay. Now you take one order pair. You take one order pair x comma y belongs to the relation. You take. Now you check that y comma x belongs to that relation or not. When x comma y belongs to the relation, if x is brother of y, if x is brother of y, see here x comma y belongs to R means itself indicates x is brother of y. X is brother of y. Okay. Here y is also brother of x. X is brother of y means y is also brother of x. This is okay when both are boys. When both are boys, x is a brother of y, y is brother of x is okay. But when one person is x is brother of y, boy, and y is girl. Suppose x is a boy, this x is brother of y. Then what about y? Y is sister of x. Y is sister of x, not brother of x. I hope you got this point. Okay. When both are boys, then this is correct. X is brother of y, y is also brother of x. But if we take like this, x is boy, y is girl. That means x is brother of y. What is y? Y is sister of x. I hope you got this point. So what we can say here, y is sister. Y is sister of x. From this we can say that y comma x does not belong to this relation. So this relation is not symmetric. By mistake, many students may suppose that it is symmetric. It is not symmetric. Okay. This relation is not symmetric. This relation is not symmetric. Here you observe not symmetric. Now you strike off the options. Here first point, it is not reflexive. Look here, this is not reflexive. When it is not reflexive, you strike off not reflexive. Okay. Now what you got? It is not symmetric also. Okay, not symmetric. Now is this relation is transitive relation? Is this relation is transitive relation? Now we need to check this relation is transitive relation or not. It's easy. How to check transitive relation? We'll take an order pair. X comma y belongs to R and y comma z also belongs to R. I'll take like this. X comma y belongs to R, y comma z belongs to R. Now what it means? X is brother of y, y is brother of z. X is brother of y, y is brother of z. From this, can I say that x is brother of z? Obviously, big brother. X is brother of y, y is brother of z. Is x is a brother of z? Yes, we can easily say that x is a brother of z. That means what? X comma z belongs to the relation. That implies this relation is what? This relation is a transitive relation. Okay. So third option is the right option for this problem. I hope you are understand. Right. Now you observe this question. What is this? R be the relation. R be the relation over the set of all straight lines in a plane. In a plane, all straight lines are there. R is the relation on set of all straight lines in a plane. Here, L1 is related to L2 in a such a way that whenever L1 is perpendicular to L2, two lines are perpendicular, then that order pair belongs to the relation. Here, suppose I need to check the reflexive property. When I can check the reflexive property, I'll take one line from this set. They are saying that set of all straight lines. Na? You take one straight line. Very good. Yes, sir. Understand. Very good. You take one straight line. You take one straight line from the set of all straight lines. Now the question is L1 comma L2. Set of all straight lines. Now I'll name it as S. Now S means set of all straight lines. Now my question is order pair L1 comma L2 belongs to this relation. When order pair L1 comma L2 belongs to this relation, sorry, L1 comma L1, L1 comma L1. Now you need to check L1 comma L2 belongs to this relation or not. Now you need to check when L1 comma L1 belongs to this relation. When L1 is perpendicular to L1, when L1 is perpendicular to L1, then we say that L1 comma L2 belongs to the relation. Is L1, every line is perpendicular itself. There is a line, man. Is it possible that that line is perpendicular to itself? No. Moreover, every line is parallel to itself, because if both the lines coincide, then we can say that every line is parallel to itself. Only here, the point is this relation is L1 comma L2 does not belongs to R. Why L1 comma L2 does not belongs to R? Every number cannot be perpendicular. Any straight line, you take one straight line, that straight line cannot be perpendicular to the same straight line. So because of this reason, we will say that this relation is not reflexive. This relation is not reflexive. That's good. This relation is not reflexive. Good. Symmetric only is the right option. Let me explain. Symmetric relation. What is symmetric relation? Symmetric relation. First you take L1 comma L2 belongs to the relation. L1 comma L2 belongs to the relation. When L1 comma, you take like this. You take L1 comma L2 belongs to the relation. When L1 comma L2 belongs to the relation. If L1 is perpendicular to L2, then only order pair L1 comma L2 belongs to this relation. As you take in L1 comma L2 belongs to R, from this I can say that the line L1 is perpendicular to L2. The line L1 is perpendicular to L2. You take two lines which are perpendicular to each other. Look here. Here two lines are there. they are perpendicular to each other. You name them. This is L1, this is L2. If L1 is perpendicular to L2, is L2 is perpendicular to L1? Obviously, L2 is also perpendicular to L1. So here what I can say, L2 is also perpendicular to L2. From this what I can say, L2 comma L1 belongs to R. So for every order pair belongs the relation L1 comma L2. L2 comma L1 also belongs the relation. Okay, right. Thank you, Suraj Kumar. I don't want to waste my time by talking with you. So, okay, it's okay. Transitive relation. This relation is symmetric relation. Now, transitive relation. I need to check transitive relation. Yes, how to check the transitive relation? I'll take a L1 comma L2 belongs to the relation. Okay, and L2 comma L3 belongs to the relation. I'll take like L1 comma L2 belongs to the relation, means L1 is perpendicular to L2. Okay, I'll take one diagram so that you can easily understand. This is line L1. Okay, L1 is perpendicular to L2. Okay, L1 is perpendicular to L2, and here look here, L2 comma L3 belongs to R. L2 comma L3 belongs to R. That means L2 is perpendicular to L3. It's okay, Suraj Kumar. Thank you very much. In case if you don't like these videos, you can leave. It's okay, no problem. Okay, don't spam the comment section. Okay, right. Thank you so much. L2 comma L3 belongs to R. That means L2 is perpendicular to L3. L2 comma L3 belongs to R means L2 is perpendicular to L2 is perpendicular to L3. Look here, L1 L2 belongs to the relation means L1 L2 belongs to the relation means L1 is perpendicular to L2. L2 comma L3 belongs to the relation means L2 is perpendicular to L3. Now you need to look that L1 L3 belongs to the relation or not. You need to look this L1 comma L3 belongs to the relation or not. You look here, L1 is parallel to L3. L1 is parallel to L3. Okay, L1 is parallel to L3. L1 L3 does not belongs to this relation. L1 L3 does not belongs to this relation. Because of this reason, I can say that as L1 comma L3 does not belongs to this relation, therefore R is not transitive. R is not transitive. R is not transitive. Okay, right. So this relation is symmetric only. Look here. This relation is not reflexive. This relation is not reflexive. This relation is not transitive. So this relation is symmetric. R is symmetric. R is symmetric. Okay. So which option is the right option? Symmetric. First option is the right option for what they are saying. R be the set of all. R be the relation on set of all lines in a plane. Same thing. Suppose S is the set of all straight lines in a plane. Okay, and L1 is parallel to L2. L1 is parallel to L2. Then the relation R is what? See here, you check that L1 comma L1. I'll take one straight line from this set of all straight lines. I'll take like this. Let L1 belongs to S. Here S means set of all straight lines. Now is every line is parallel to itself. L1 comma L1 belongs to the relation. Every line parallel to itself. We can say there is a line which is parallel to itself. That means it coincides, right? So this is correct. This is correct. I can say like this, L1 comma L2 belongs to R. From this what I can say? I can say that this relation is reflexive relation. Okay. Now I'll take one order pair from the relation. L1 comma L2 belongs to the relation. I'll take. This is symmetric condition I am checking. Symmetric condition. If I take L1 comma L2 belongs to the relation, that means that L1 is parallel to L2. If L1 is parallel to L2. You look here, I'll take two lines. L1 parallel na. I'll take two lines L1, L2. These two lines are parallel. If two lines are parallel, L1 is parallel to L2. Can we say that L2 is parallel to L1? Yes, L1 is parallel to L2. L2 is also parallel to L1. So what I can say from this? This implies L2 is parallel to L1. That implies if L1 comma L2 belongs to R, L2 comma L1 also belongs to the relation. Because of this reason, I can say that this is symmetric. This relation is reflexive. This relation is symmetric also. Okay. Now I'll check for transitive property. Transitive. What is transitive property? You take L1 comma L2 belongs to the relation and L2 comma L3 belongs to the relation. You take like this L1 comma L2. Relax, saying sir, I am your subscriber and my friends also following. Thank you very much. Thank you. Right. You take such order pairs A comma B, B comma C. Now you look for A comma C. Here the point is I'll take when L1 comma L2 belongs to R. As per this, when L1 is parallel to L2, then only it belongs to the relation. Here L1 is parallel to L2. I'll take here L1. This is the line L1. L1 is parallel to L2. Suppose name it as L1, L2. As this belongs to the relation, L2 comma L3 also belongs to the relation. What it tells you? It tells you that L2 is parallel to L3. This is already L2 na? I'll take something like this. L2 is parallel to L3. These two lines L2, L3 are parallel. Now my question is, are L1, L3 are parallel? Yes, L1, L3 are parallel. So L1 comma L3 are parallel. It belongs to the relation. So what happened? This relation is transitive. This relation is reflexive. This relation is symmetric. This relation is transitive. If a relation is reflexive, symmetric and transitive, then we say that that relation is a equivalence relation. So for this, fourth option is the correct option. Relax. I hope you understand this. Right? Good. Now, next question. All of you observe this. What they are saying? R is a relation on the set of all triangles in a plane. R is a relation on set of all triangles in a plane. Now, one triangle is congruent to another triangle. Then those two triangles belongs to this relation. Relation contains set of all order pairs. Now, if triangle 1 is congruent to triangle 2, then that triangle 1 is congruent to triangle 2, then that order pair belongs to this relation. That is what they are saying. Now, the question is very good. That question is this relation is reflexive? Every triangle is congruent to itself. Here congruent means what? Look similar. For example, you observe here I considered two triangles are there. Are these are congruent or not? If I coincide one on the other, they must match. For example, you look here. You observe here, they both coincides. You can observe here, both coincides. That means these two triangles are congruent triangles. I hope you are getting. If I keep like that, easily you can say. But if I rotate it like this, you may confuse. They are congruent or not. Congruent means if one is overlapped on the other, they must look same, right? So here, every triangle is congruent to itself. Yes, this relation is reflexive. No doubt in that. Because every triangle is congruent to itself. Okay. Now, is this relation is symmetric? You take two triangles. T1 is T1 comma T2. Two triangles you take in the relation. When two triangles belongs to the relation, then I can say that first triangle is congruent to second triangle. If T1, T2 are congruent, T2 comma T1 also congruent. Yes, look here. These are T1, T2. These two are congruent. This is congruent to this. At the same time, this is also congruent to this. It can be understood easily. Okay, that implies what I can say. T2 comma T1, this belongs to the relation. T1 comma T2, T2 comma T1, both are belongs to the relation. One Pankaj Kumar, one means what? Reflexive you are saying. Yes, it is reflexive. It is reflexive. Reflexive, I written here. This I am checking for symmetric condition. Symmetric condition I am checking. I taken T1 comma T2 belongs to the relation. T2 comma T1 also belongs to this relation. That means this relation is symmetric also. For reflexive, yes, it is reflexive. Symmetric, yes, it is symmetric. Now you need to look for transitive. Transitive, is it is transitive? Transitive relation, yes, transitive relation. What is transitive relation? You take T1 comma T2 belongs to the relation. Okay, and you take T2 comma T3 belongs to the relation. That means what? T1 is congruent to T2. T2 is congruent to T3. For example, here I'll take look here. Here three triangles are there. We know that these two triangles are congruent. Which two triangles? T1, T2. Look here. This is T1. This is T2. This is T3. Actually, all triangles taken from one triangle only. It can be easily. I can overlap one triangle on the other. T1 comma T2 belongs to R means these two are congruent to each other. T2 comma T3 belongs to R means these two are congruent to each other. Is T1 is congruent to T3? Yes, it is very easy to say. It is very easy to say. I hope you are understanding. So we can easily say that the T1, T3 belongs to the relation. Therefore, this relation is transitive. Yes, this relation is transitive. This relation is reflexive. This relation is symmetric. This relation is transitive also. So we say that this relation equivalence relation. I hope you understand. So we'll take some problems which are given in previous year JEE papers. We'll take those questions and we'll solve those problems. Okay, you see this question what they given set A is 3, 6, 9, 12 and the relation is given like this. They given one relation. Okay, they are asking what this relation is. This is a reflexive and transitive only. Okay, this is reflexive only. This is equivalence relation. This is reflexive and symmetric only. Which option is correct? Okay, first we will check a reflexive part. If you take 3 in set A, order pair 3 comma 3 is there. Okay, if you take 6 in set A, order pair 6 comma 6 is there. If you take 9 in set A, order pair 9 comma 9 is there. If you take 12 in set A, order pair 12 comma 12 is there. That means for every A belongs to set A implies order pair A comma A belongs to the relation. So this relation is reflexive or not? Yes, this relation is reflexive. I written here, this relation is reflexive relation. So now I'll check symmetric also. This relation is symmetric or not. You observe this 3 comma 3, 6 comma 6, 9 comma 9, 12 comma 12. This type of elements always pass symmetric test, and this type of elements always pass transitive test also. So for these elements no need to check symmetric test. See, symmetric, yes, that means for 6 comma 6 reverse order is also 6 comma 6. This passed the symmetric test. This also passed the symmetric test. This also passed the symmetric test. Now come to this. Here order pair 6 comma 12 is there. For order pair 6 comma 12, 12 comma 6 is there in the relation. You check, 12 comma 6 is there in the relation. No, 12 comma 6 does not belong to the relation. When it comes to symmetric, it is no, it's not symmetric. I hope you are understanding. So this relation is reflexive but not symmetric. You observe here, we can strike off this equivalence relation. You observe here, this cannot be equivalence relation because it is not symmetric relation. Okay, and we can strike off this fourth option also, reflexive and symmetric only. This is not symmetric. So now two options are there. So we must check transitivity, right? Okay. How to check the transitivity? You, in general, you observe for A comma B, B comma C, A comma C doesn't exist or not. See, these elements always satisfies transitive condition. No need to check transitive condition for these elements. Okay. You just check. See, this you take this order pair ends with 12. You look, any other order pair starts with 12? No, no other order pair starts with 12. So in that case, we say that this element passed the transitive test. Okay. If any other element starts with 12, suppose this is 6 comma 12, any other element is there, something like 12 comma 3, then we look for 6 comma 3 is there in the relation or not. If I take 6 comma 12, this ends with 12. Is there any other order pair starts with 12? No. In that case, we say that this element passes the transitive test. This element passes the transitive test. Okay. Now come to this 3 comma 9. This ends with 9. Is there any other order pair starts with 9? No other order pair starts with 9. In that case, we say that 3 comma 9, this element passes the transitive test. Okay. Right. Now this ends with 3 comma 12. This ends with 3 comma 12. Any other order pair is there which starts with 12. Actually this is there, but this type of things, suppose you take 3 comma 12, 12 comma 12. What is A comma C? A comma C is 3 comma 12. That is there here only. That's why we are not checking. These elements always satisfies transitive condition. No need to check. Okay. Now this ends with 12. Any other starts with 12. You just observe here only. Any other starts with 12. No. So this element also passes the transitive test. Okay. Come to this last one, 3 comma 6. This ends with the 6. Any other order pair is there which starts with the 6? Yes, here it is, 6 comma 12. Look here, this ends with the 6. This starts with the 6. So we found that 3 comma 6, 6 comma 12 in the relation. What is A comma C? A comma C is 3 comma 12. You look that 3 comma 12 is there in this relation. Yes, you observe here, 3 comma 12 is there in this relation. So this relation transitive or not? This relation is transitive or not? Yes, this relation is transitive. So this relation is reflexive and transitive. So which option is right option? You look here, first option is the right option. This relation is reflexive and transitive only. I hope you understand this solution. You observe this question. This is given in JEE Main 2023. Usually this much easy questions. This is very easy actually. This type of easy questions usually we won't get. Particular batch may get this question. Lucky batch, we can say that that batch is a lucky batch. Very easy question they got. See what they given. They given set A 1 2 3 4 5 6 7. All 7 elements are there. They given like this: R equal to order pair x comma y, and x belongs to x. This order pair belongs to A cross A. That means this itself indicates that R is a relation on A. Okay, and this order pair satisfying this equation x plus y equal to 7. Now you need to check this is a equivalence relation or You see, the second option is symmetric, not reflexive, not transitive. Third option, it is transitive, neither symmetric nor reflexive. Reflexive, neither symmetric nor transitive. Okay, here as A is a finite set, and this relation we can easily write in a roster method. We can list this relation very easily. So I'll list this relation, right? I'll write this relation in roster method. Okay, R equal to, you see here, x comma y belongs to A cross A. Na? So x is belongs to set A, y is also from set A. What I'll do, I'll take x is 1. Okay, you take x is 1. What is y from this? I'll write here. What is y from this? Y is 7 minus x. Okay, so you take x is 1. You put x is 1 here. 7 minus 1 is 6. So what is the order pair? The order pair 1 comma 6 belongs to this relation. I hope you are understanding. You see, 1 is there in set A, and this, when I substitute in this, it satisfies. 1 plus 6 is 7. Okay. Now you take x is 2. You take x is 2. Substitute x equal to 2. 7 minus 2, 5. 5 also must be in set A, right? 5 is there. Okay. 2 comma 5. Okay. You take x is 3. Put x equal to 3 in this. 7 minus 3 is 4. Okay. You put x equal to 4. 7 minus 4 is 3. 4 comma 3. If you put x equal to 5, 7 minus 5 is 2. If you put x equal to 6, y is 1. So 6 comma 1. You put x equal to 7. When you put x equal to 7, y is 0. As they given x comma y belongs to A cross A, as 0 is not in set A. So we cannot take that. So what happened here? I written given relation in roster method. Now checking this relation, reflexive, symmetric, transitive, is very easy. I'll check a reflexive. Okay, whether it is reflexive or not. 1 is there. 1 comma 1 is there in this relation? No. So this relation is not reflexive. Best method is try to eliminate the options, right? Here they are saying it is reflexive. That means fourth option is not correct. Okay. And first option they are saying equivalence relation. It cannot be equivalence because it is not reflexive. Okay. Now I'll check symmetric. How to check symmetric? You take A comma B, B comma A is there in this or not? For 1 comma 6, 6 comma 1 is there? Yes, it is there. For 2 comma 5, 5 comma 2 is there? Yes, 5 comma 2 is there. For 3 comma 4, 4 comma 3 is there? Yes, here it is. For 4 comma 3, 3 comma 4 is there. For 5 comma 2, 2 comma 5 is there. For 6 comma 1, 1 comma 6 is there. So clearly this relation is symmetric. It is symmetric. Now you can eliminate some options. You see they given it is not symmetric. Actually it is symmetric, right? So we can strike off this. Now you see, without checking transitivity, we are easily can say only one option is remaining, right? So this relation is symmetric, not reflexive, not transitive. Just check transitivity. You observe here, this is 1 comma 6, this is 6 comma 1. 1 comma 6, 6 comma 1 exist in the relation. What is A comma C here? A comma C is 1 comma 1. 1 comma 1 is there in the given relation? No, 1 comma 1 does not belong to this relation. So this relation is transitive? No. So what is the right option? This relation is symmetric only, but neither reflexive nor transitive. So second option is the right option. I hope you are understanding these things. You observe this question. This is given in JEE Main 2024. Easy only, but a bit tricky one. Let's see. First observe the question. They given one set. S is 1, 2, 3, 4 like that. 10 elements are there in it. M is what? Set of all subsets of S. That means M contains what? Something like this. M contains like 1, 2, 1 comma 2, 1, 2, 3, all subsets of this set S. Okay. R equal to order pair A comma B. They mention that A comma B from this set M, and the relation between A and B is A intersection B is not a empty set. Okay, right. Now you need to check what type of relation it is. Reflexive, symmetric and reflexive only, symmetric only, symmetric and transitive only, reflexive only. Which option is right option? Okay, first we will check reflexive. Usually what we check for any A will, one point here, as they mention R like this, order pair A comma B belongs to M. This R is a relation on which set? It indicates that R is a relation on M, not S, sir. Okay, so this A also belongs to M, B is also belongs to M. That's why R is a relation on M. Now I need to check reflexive. What way I'll check? For every A belongs to M implies, order pair A comma A belongs to the relation or not. This I need to check. Here you take any one set A from M. Usually A intersection A is what? A intersection A is A. Generally A intersection A is A. A union A is A. We know these things. But in a particular case, suppose I'll take A is empty set, because empty set is there, set of all subsets of S. Empty set is a subset of S. If I take A as empty set, what is A intersection A? A intersection A is empty set. I hope you are understanding. In this case, when I take A is empty set, in this case, order pair A comma A does not belong to the relation. See, if we give one example which is not satisfying the given condition, we can say that it is not reflexive. Here, I can give so many examples such that if A is not empty set, A is non-empty set, A is other than this set, you take A as any set, that order pair belongs to this relation. You take A is equal to something like this, 1 comma 2. A intersection A is what? A intersection A is 1 comma 2. I hope you are understanding. I think little bit more explanation is given. It's enough. It can be understood that this relation is not reflexive. You better avoid the options. Which options we can delete? They given that it is reflexive only. No, it is not reflexive. They given here it is a symmetric and a reflexive only. We can eliminate. Eliminating the options will gives you some clarity. Unnecessary confusion we can avoid, right? So better you eliminate the options. Now I'll check symmetric condition. What is symmetric condition? If you take one relation A comma B, if you take one order pair A comma B in the relation, then you need to look that B comma A also belongs that relation or not. Okay, so what I'll do here, if A comma B belongs to R means what do you know? You know that A intersection B is not a null set. That is the point now. If order pair A comma B belongs to R means A intersection B is not a null set. If A intersection B is not a null set, 100% B intersection A also not a null set. This is very clear. 100% B intersection A is also not a null set. Then what I can say? I can say that the order pair B comma A belongs to R, right? So this relation is symmetric or not? Yes, this relation is symmetric. Reflexive, not reflexive, it is not reflexive. Symmetric, yes, it is symmetric. Now you look, can we decide which option? You look here, they given symmetric only. They given symmetric and transitive only. So you need to check transitive also. You don't have any other alternate. Okay, how to check transitive condition? You take one example like this. I'll take A as 1 comma 2, B as 2 comma 3 and C as 3 comma 4. I'll take one example like this. You can observe that these elements must be there in set M, right? Yes, okay. Now you take A comma B belongs to R or not? A comma B. When A comma B belongs to R, if A intersection B is not a empty set, calculate A intersection B. 2 is the element common, na? A intersection B not empty. This is clear. Okay. A comma B belongs to R and you look that B comma C. B comma C belongs to the relation. B comma C. When B comma C belongs to R, if when I calculate B intersection C, you must get non-empty. B intersection C. See, 3 is the common element. So B intersection C is non-empty. So I identified A comma B, B comma C in the relation. Now you look that A comma C is there in the relation or not. Now you look that A comma C. A comma C, when this belongs to the relation, when I calculate A intersection C, I must get null, not a null set. A intersection C. Calculate A intersection C. There is no element in common. So when I do this, you are getting, it's a null set. So what I can say? I can say that A comma C does not belong to the relation. So here, A comma B belongs to R, B comma C belongs to R, but A comma C does not belongs to R. From this we can say that this relation is not transitive. So this relation is not reflexive, symmetric, not transitive. So which option? Symmetric only, right? This is the right option, right? Second option is the right option. I hope you understand.